This question describes the mathematical relationship between the amount of ice above the of an iceberg and the total amount of ice in the iceberg. Now, for questions like this, where you have some sort of word problem, your job is to translate that to some math equation and then take that math equation and plug out an answer to whatever questions that they give you. This is the step usually where most people, including myself, have problems. For a lot of questions like these, the actual calculations that you're going to do are going to be pretty straightforward, but it's taking the information in context and distilling it somehow down to actual math that we can do. So to answer this question, we're going to take a little bit of time and make sure that we understand exactly what we're given and what we're being asked to calculate. So there's two variables in this equation. The first is V, which is the total ice in the iceberg, and the units that they give us for that one are kilometers cubed. It's important to note that if they give you variables with units in them, then the answer that you send out also has to be in units. So this is something that we're going to be keeping track of throughout the problem. The second variable that they give us is S, which is ice above the surface of the water. I'm not going to write all of this out because it's not overly important. This is just to remind us exactly what we have and how we're going to deal with it. Now, the equation that actually makes this question interesting that relates these two is that V is equal to 9.5 S. And the structure of the questions that were asked is they're going to give us one piece of information about this equation, and we're just going to have to find the other one. Writing out all of the information like this is helpful for a couple of reasons. One, it really makes you understand what everything is. And also, now I don't have to look back at the big long paragraph or two if I forget what S is or what the equation is. I just have this nice little cheat sheet for myself. And, at least for me, I'm far less likely to make mistakes with this amount of information than I am with 2 paragraphs worth of information. So for the part A of the question, we are given explicitly that S is 4 kilometers cubed, and they want us to calculate what V is. And the way we're going to do this is this equation. We have an equation with 2 variables in it, and we know one of the variables, so we can always calculate what the other one is. So the first step to this is just to, pretty naively, just write out what the equation is. And whenever you're trying to solve for a variable, you want to make sure it's by itself on one side of the equal sign so that we can plug in everything else over here, calculate it out, and then we get the answer that we want. So for here, it's just a pretty simple substitution. Because we have that S is exactly 4 kilometers cubed, whenever we see an S, we can just replace it with 4 kilometers cubed and go through and calculate what the actual answer is. Units are multiplied in the same way that variables and numbers are. So actually, we're going to group this. We're going to group these two together and multiply them. And we have 9 times 4 is 38. And then we tack on the units at the end, which is kilometers cubed. Now, a good sanity check, which was great because we did all this preparation up here, is just to do our units for V and the answer that we're claiming match the same that we know it has to be from the problem. And in this case, yes, we have kilometers cubed here and kilometers cubed here. This was kilometers squared or feet per second or inches per pound or any kind of crazy unit. We would instantly know that there's no way we got the right answer. Now we're a little bit more confident that this is correct, given that we have the right units. It's important to go through and check to make sure that your math is still correct, but we're a little bit sure that our process at the very least is right. This is a good habit to get into, maybe not for these simpler problems, but whenever you're dealing with a lot more complicated stuff. So you might have 5 or 6 variables and 4 or 5 equations. Doing this kind of prep work is going to be incredibly important. And also, if you're doing this on a test or a quiz, then it's really easy to go back and check your work and see, okay, I had these variables and I did this process and I got this answer. And you might be able to see something that you did wrong very quickly. So for part B of this question, it's just the reverse of the first. We're given information about V, which is that it's 19 kilometers cubed. And they want us to calculate what S is. This is no more difficult than the previous one. It just requires an extra step. Because when we write out our equation, we see that the thing that we want to solve for, S, is not by itself. So we have to isolate it. So the thing it's being multiplied by is 9.5. So we want to divide both sides by 9.5. We have the same thing that's on the top of the bottom here. So these cross out, and we're just left with S by itself. So I'm going to rewrite that as just S is V over 9.5. And then we can plug in the value that we were given for V. So when we plug in 19 kilometers cubed over 9.5, we get that S is 2 kilometers cubed. Running out of space there at the end. So again, quick unit check. Does kilometers cubed make sense for S? Yep, because we wrote it right here. And another important thing to note when you're doing these problems is it's usually a good idea to save plugging in the numbers for the end. You could just immediately take this equation and plug in 19 kilometers cubed here, but at least I am far more likely to make mistakes with numbers than variables. And there's track of here. So it's usually a good habit to get into to manipulate all of your variables first and then plug everything in. It usually makes it a lot easier to check your work. And if someone else is trying to figure out what it is just a lot cleaner to read. Hope that was helpful.